Hello, welcome to today's tutorial. Today we'll be looking at how to use Frobenius method to solve a differential equation. So we are given this differential equation 3x y prime plus y prime minus y equals to 0. So using Frobenius method, y is equal to summation from n equals to 0 to infinity of an x c plus n, where c is a constant and n is from 0 to infinity. Okay, so if this is y, what will be y prime? So I will say y prime, which is just like differentiating y one time, will be summation of n equals to 0 to infinity. So you are differentiating with respect to x. So what am I going to have? I'm going to have c plus n. Let me put it in brackets. C plus n, because when we use this to multiply the coefficient. So an, then x c plus n, we minus 1 from the power, minus 1. So what we basically did was that we used the power, which is c plus n, to multiply the coefficient. We have an as the coefficient here, a subscript n, that's what we wrote there. Then if we multiply that, you have c plus n times an, right? And when you are differentiating, you minus 1 from the power. So minus 1 from the power c plus n minus 1. Okay, so you can go ahead and find for y prime prime. Okay, so what are we going to get for that? We put the summation sign. Then, okay, so go ahead and differentiate this. What are you going to have? That means you use this power again, which is c plus n minus 1, to multiply the coefficients, which is now c plus n an, because we are differentiating this the second time. So I'm going to have something like c plus n minus 1 into c plus n and an. Okay, so I'm going to put this xc plus n. So I'm going to have minus 1 minus 1. So if I add minus 1 together, I'm going to have minus 2 here. So that's y prime prime. Now we have y, we have y prime, we have y prime prime. So in Frobenius method, we substitute this into the equation that we are given. So if you remember, the equation we are given is written up here as 3x y prime. So what is our y prime? We are going to replace this as y prime. So which will be summation n equals to 0 to infinity c plus n minus 1 c plus n an x c plus n minus 2. Okay, that's 3x y prime, 3x y prime. Okay, plus y prime, right? So plus y prime. What is your y prime? You are given here now. You have your y prime as summation of n equals to 0 to infinity of c plus n. Right, that's the bracket. So c plus n an x c plus n minus 1. Okay, now minus y. So there's no space there, so let me write it here, minus y. So y is given as this. Turn of n equals to 0 to infinity of an x c plus n. So which is equals to 0. All right, so that's what we have. Now you can see we can expand this guy here, 3x multiplied by this. So only the x is going to multiply the x, because that's a common variable that is there, xx. So we're going to multiply x with x, and when we multiply two powers together, that means when we multiply two variables together, their powers is going to add. So we add their powers together. So that's what we'll be doing there. We have 3 into, so it will now be 3 into summation of n equals to 0 to infinity of c plus n minus 1, c plus n into a n x. Now that means I've multiplied this x with this x, which is the power here is 1, as you all know. Then if we add this one to c plus n minus 2, what's it going to give us? So it's going to give me c plus n minus 1, because plus 1 minus 2 will give me minus 1. All right. So plus summation of, so I'm going to repeat the remaining. Okay. Now we have this. Now the next thing I'm going to do is that I'm going to say here I have c plus n. I want to make it in form of this. I'm only having c plus n here. But I can see the power here is c plus n minus 1, and the power here is c plus n minus 1. So what can I do that will make me just have c plus n, just like this? So basically what I'm going to say is that I'm going to say anywhere I see n in this first expression and this second expression, because they are both having the same power, c plus n minus 1, c plus n minus 1. So I'm going to say in this expression here, the first one, and the second expression here, I'm going to say anywhere n is, I'll say n should be equal to n plus 1. Okay, why did I say that? I basically want to make this looks like this, c plus n, because when I put this n, when I place this n as n plus 1, this plus 1 minus 1 will give me, we cancel out, right? So I'm going to have c plus n left. But I'm not going to, because I'm saying anywhere I see n, I should put n plus 1. So that means it's not only here that is having n, here is having n, here is having n, n. So anywhere I see n in these two expressions, I'm going to put n plus 1. So let's do that. I'm going to have 3 into summation of. So when I put n plus 1 as n here, I put n plus 1. That means if I take, so I'm going to be basically be having something like n plus, I don't know if you see that, I'm going to be having n plus 1 equals to 0. Then when I take plus 1 to the other side, I'm going to have n minus 1 here. So what I'm going to be having here is n equals to minus 1. And then here I'm going to have c plus, so if I put n plus 1 minus 1, so I'm going to have n, right? You can try that on your own. Then when I put n plus 1 here, I'm going to have c plus n plus 1, right? Okay. I place this as n plus 1, I'm going to have n plus 1. All right. I place this, okay, my x first. So I place this with n plus 1. What will I have? I will have c plus n, right? So it's now in form of c plus n, as we can see. I'm going to do the same thing for this second one. It's also having n minus 1 here. So I'm going to be putting n plus 1 anywhere I see n. So here I'm going to be having n equals to minus 1, just like here. And to infinity of c plus n plus 1, right? Because I said anywhere I see n, I should put n plus 1. I'm going to be having a n plus 1. And I'm going to have x to the power of c plus n. Then this one is already in c plus n, so I'm not going to be putting n plus 1 here. Okay, so I'm going to be having minus summation to infinity from n equals to 0 of a n x c plus n equals to 0. So take a minute to look at this and figure out what we did. Okay, so now I have this to be n equals to 0, right? That's my summation is starting from n equals to 0. But you can see here I have my summation starting from n equals to minus 1. And here my summation is starting from n equals to minus 1. So actually what I'm going to do is that I want to make this one to also start from n equals to 0, because from the general formula it's telling us that n should start from 0. So I'm going to find a way to make this n equals to 0, n equals to 0. Now what am I going to do? Let's recall from, let me say recall. When we have something like from your mathematics, when we have n equals to, let me say, n equals to minus 2, let's use minus 2 now, to infinity of, let's say, something like t raised to power 2, okay? Or let me use t here. So when t is from minus 2 to infinity, and we want to, let's say I want to make this in form of, I want to stop at t raised to 0, you get? I'm going to be saying something like, this thing is equal to minus 2 raised to power 2, right? Then I'm going to be dropping it because it's going to infinity, so positive infinity. So I'm going to be saying minus 1 raised to power 2. I'm going to say 0 raised to power 2, right? Then I can say plus till infinity. So let me say I want to stop at when n is when t is 1 here. Then I'm going to say plus summation of when n is equal to 1, infinity, then t squared. No, because this has also represented when n is from 1 and above. So the same principle that I use here is what we are going to use here. That okay, we are going to, when n is equal to, we want to make it in form of n equals to 1, like n equals to 1 here, but we want to make it in form of n equals to 0 as of these ones. So I'm just going to replace when n equals to minus 1 in this expression, and when n equals to minus 1 in this other expression, right? So when I do that, I'm going to leave it in form of, leave the rest in form of n equals to 0 to infinity. So now let me do it so that you will understand what I'm trying to say better. So when I put, let me make a big bracket here. So when I put n equals to minus 1 into this expression, what am I going to have? N is minus 1. So if I put minus 1 here, I'm going to have c, okay, make a bracket there. I'm going to have c minus 1, right? Okay. Then when I put n equals to minus 1 here, what am I going to have? I'm going to have c plus n, right? Okay, sorry. When I put n equals to minus 1, so we don't need to have n again. I put minus 1 plus 1, so that will give me 0, right? Yeah, 0. All right. So when n is minus 1 plus 1 give me 0, right? A naught. So I'm going to have x to the power of c minus 1. Is it not? Okay, so I can close the bracket. So now this is when n equals to minus 1. When n equals to 0, right? Because we are going from minus 1. After minus 1, we are going to positive infinity. So after minus 1, I'm going to meet 0. Then I'm going to meet 1, 2, 3, and so on like that. So I'm going to leave it as when is in form of 0 now, because we move from minus 1 to 0 to 1 to 2. So when n equals to 0 till infinity, I'm going to leave it in form of summation. So I'm going to repeat this: c plus n, c plus n plus 1, a n plus 1, x c plus n. Okay, so there will not be space here. I'm going to turn back and write the rest. So I'm going to say when n equals to minus 1 in this expression too. So that's what I'm going to do here. Then I'm going to say That's when n equals to minus 1. So look at this very well. When n equals to minus 1 here, what am I going to have? I'm going to have c, right? Because minus 1 plus 1 will give me just c. And when I put n equals to minus 1 here, what am I going to have? I'm going to have minus 1 plus 1, which is 0. So I'm going to have a naught c, right? Or c a naught, anyone you want to call it. So I'm going to have here c in the bracket. I'm going to have a naught followed. Then I'm going to have x raised to power c minus 1, right? Because if you look at it, I'm having c plus n. So if I put minus 1 here, so as if I place n as minus 1, I will have c plus c minus 1, right? Okay, so I'm going to repeat this now for when n equals to 0 to infinity. So I'm not going to put the values. So I'm going to have plus summation of n equals to 0 to infinity of c plus n plus 1 into a n plus 1 x c plus n. All right. Okay, so we have successfully made this expression in terms of n equals to 0, right? Okay, and we have also successfully made this in form of n equals to 0. And what's next? We repeat this because it's already in form of n equals to 0 and already in c plus n as the power. So I'm going to just put it there and say minus summation of n equals to 0 to infinity of a n x c plus n equals to 0. Okay, sorry. Now, what's next? We have successfully, as like I said, we have successfully made this to be n equals to 0 and the power c plus n equals to 0, c plus n. So everything is in order now. What do? We now equate coefficients together on both sides. The right hand side should be equal to the left hand side. Yeah. The coefficient on the right hand side should be equal to the coefficient on the left hand side. So we are going to look at, let's simplify this guys first. So when I have 3 times, so I'm going to have here 3 times c, I'm going to have 3c, right? Then 3 times 1. So let me just bring that down. I'm going to have 3 into brackets c minus 1. Okay. Then this will give me c a naught. So let me say a naught c, right? X c minus 1. Okay. That's the first expression. Then we'll repeat this. So plus summation of n equals to 0 to infinity of 3. Okay. C plus n plus 1 a n plus 1 x c plus n, right? So yeah, I'm correct. Then for this one, a naught times c will give me plus a naught c, right? X c, so that's minus there, minus 1. And I'm going to continue the rest here. Summation of n equals to 0 to infinity of this. So I have c plus n plus 1 a n plus 1 x c plus n. I'm going to write this to okay. So we'll find the one that have one specific power and equate the coefficients to the one that has that same power on the other side. So this is the right hand side of the equation. After the equal to is the left hand side, and we see that this is the right hand side. After the equal to is the right hand side. After before the equal to is the left hand side of the equation. So you see that on the right hand side of this, we are only having 0 as our answer. Okay, so that means anything we are going to be equating, we equate to 0. Now, if we look at the power that I have, there is a power that is x c plus 1. So let me say, how will I put it? So we are going to look at xc plus the one that have xc minus 1 as the power. You see it's only 2. So we'll add those powers together and equate them to the other side. What did I mean? So I'm going to say, let me expand this. So let me not expand this yet. Let me say 3 into c minus 1 a naught c, right? So plus a naught c. That's this one. I'm leaving the, I want to factorize out this xc minus 1. So with this one, this plus this into xc minus 1, right? Equals to 0. Why did I say equals to 0? Because there is no one having x raised to power c minus 1 on the right hand side of the equation. So this can cancel this, right? You can have, if we divide 0 divided by this, will still give us 0. So I can cancel that out. And then because a naught c is common, so I can factorize it out as a naught c into 3c minus 1 plus 1, right? Because I've tried to factorize this out from here, it becomes 1. So I factorize this out, remain 1. All right, equals to 0. Now, so as I factorize the a naught c out, for this one, I'm going to be left with 3c minus 1, right? Because I factorize this out. So this is it, yeah. If I factorize a naught c out here, so I'm going to be left with 1. Just like saying a naught c divided by a naught c gives us 1. So, all right. So basically I'm going to say, let me expand this bracket inside. I'm going to have 3c, right? So 3c, I'm going to have 3 times minus 1 will give me minus 3. So if I say minus 3 plus 1 will give me minus 2. So you can look at that carefully and you'll see what we did there. Okay, so when you have expression like this in mathematics, then you have two roots, right, for the equation. You can say a naught c equals to 0. So what we see give me from here, I'm going to be saying c can be equal to 0 because when I divide 0 divided by a naught will be 0. And I can have another root which says 3c minus 2 equals to 0. From this, a naught c equals to 0 or 3c minus 2 equals to 0. So from this, I can have that c is equal to 2 over 3, right? Okay, so we have gotten the value of our c. C is equal to 0 or c is equal to 2 over 3. Okay, that's by the way. Then remember, we got this by equating the coefficient of the power x raised to power c minus 1. Okay, then we are going to do now for when for the power x equals to c plus n. So we are going to equate those coefficients. So let's leave the summation sign aside first. Let's leave it aside and let's talk about the coefficients. So for the first one, this expression, I'm going to just take this out. So yeah, I'm going to take that out. So I'm going to have 3 into c plus n and c plus n plus 1. an plus 1. So that's I said let's leave the summation sign aside. So we will still use it later then. Okay, for this one, so what am I going to bring out? I'm going to just take this carefully. Okay, so plus c plus n plus 1 an plus 1, right? Okay, so if you look at this, I'm only having an, right, before the power, okay, before the xc plus n. So, and is having a minus sign there. So I'm going to minus an. I'm going to equate it to the one that has the power x raised to power c plus n on the right hand side. And if you see on the right hand side, there is no one having, so it's 0. I'm going to equate it to 0. Okay, you can see that this is having an plus 1, but this is only having an. So I can move this to the other side, right? Okay. And I want to make an the surrogate of formula. So I'm just going to take that at the same time. Okay. So I'm going to make an plus 1 the surrogate of formula now. I'm going to do that at the same time as I'm taking this to the other side. So an plus 1. Okay, I think let me take it step by step so we will not be confused. So let me say I want to factorize an plus 1 out from this 2. So what will I have? I'm going to have 3c plus n, c plus n plus 1. When I factorize this out, I'm going to be left with these guys alone. Okay, when I do that for the other time, I'm going to other part, I'm going to have c plus, sorry, that's a bracket, and then c plus n plus 1. So I'll factorize this out, which is outside. I'm going to close the main bracket. Then I'm going to take minus an to the other side, which is an. So what will I do? I divide both sides by this expression, right? Because I want to make this the surrogate formula. So I'm going to have an plus 1 equals, so let me have this. So you can see this 2 is also common here. So let me see factorize it out there. So I have c plus n plus 1 factorized out. You know, I'm dividing by this now. I'm dividing this by the whole of this. But this is still common, so let me factorize it out. And in the bracket, what will I be left with? I'll be left with 3 into c plus n, right? Plus 1. Because when I factorize this out, it will be left with 3 into c plus n. Then when I factorize this out, it will be left with 1. Okay, so I think it's simplified that way. Then, yeah, I divide by a. So I can replace my summation sign back. N equals to 0 to infinity, right? That's where we are. N equals to 0, n equals to 0 to infinity. Okay. Then this is also summation of from n equals to 0 to infinity. So that means I can get my I can say when n equals to 0, then I'll get what this expression will look like when n equals to 1, when it's 2, when it's 3, till infinity. Okay, so we will only do to like maybe 3 or 2, and then we stop there. You can continue to like 5, maybe in your assignment or in your test or anything like that. And then for the c, we have two values for c now. We have when c is 0 and when c equals to 2/3. So we are going to do for when c is equal to 0, then for when c is equal to 2/3, and then we write the expression. So when c is, let's start with when c equals 0. So anywhere I see c in this expression, I'm going to be putting 0. Then I'm going to start this from n equals to 0 to 3. I'm going to stop at 3. So I said for your test, for your exam, you can stop at 5. Okay, so when is equal to 0, what will I have here? We have 0 plus 1, right? N equals to 0 plus 1 because n is starting from 0. So 0, anyway, I see n now, I want to put 0 first. So I'm going to say when c is equal to 0 and n equals to 0. So this will be a1 equals to a0, right? Divided by. So when I put 0 plus 0, 0, right? This is left with 1. I'm going to have 1 in this bracket. Then I'm going to put 0, 0 here. 0 plus 0, 0. 3 times 0, 0 plus 1. So I'm having plus 1 here. So what will I have? I will have that A1 is same thing as A0. Okay? When okay, so I'm supposed to write let's now take for when we are still dealing with when c is equal to 0. So at n equals to 1 now, when n equals to 1 and c is remaining 0. So what am I going to have here? I will have 1 plus 1. I'm going to have 2 as this one. So I'm going to have this one as a1, right? Plus an, so a1. Divided by, so in this bracket, what will I have? 0 plus 1 plus 1, that's 2. I'm going to have 3 into 0 plus 1. So that's 3 times 1. That's 3 plus 1. That's 4. So I'm going to have that a2 is equal to a1 over 8. Right? Okay. Now, for when n is equal to 2, we're going to have a3, right? Because 2 plus 1. So then on this side, I'm going to have a2 over, I'm saying that n is 2 now. So 0 plus 2 plus 1, that's 3, right? Okay. 3. Yeah, what will I have? This is 3, right? Okay, this is 0 plus 2. That's 2. 2 times 3, 6, right? Plus 1, that's 7. So I have 7 here. Okay, so what will I have? I will have a2 over 21. A2 over 21. But remember from here, I have that a2 is equal to a1 over 8. So, and I can still write this as a0 over 8 because I said that a1 equals to a0. So, then I can write, instead of this a2, I can replace it as a0 over 8. That's over there. Then over 21, which will give me a0 equals over 8 times 21. Right? Okay. So what will I have there? I have a0 equals to equals to 168. Alright. So I say I'm going to start at 83. 83. So I'm going to stop there. Then that's for when c equals to 0, right? Okay, so let's now start from when c is now 2 over 3, and we'll now take n 0 from 0 to 2 also, like that, just like that. So I'm going to start from when c is equal to 3 now. All right, so I'm going to say when c is equal to 2 over 3 and n equals to 0 the first time. So look at our expression again. Carefully look at it. All right, this is the expression here. So I'm going to have a1 equals a0, right? So here I'm going to have 2 over 3, all right? Because c is 2 over 3, right? So I'm going to have 0 plus 1. So I'm going to have plus 1. Yes or no? Okay. So here I'm going to have 3 into bracket what? Because this is now 0. This is now 0, right? So this is 2 over 3. That will be 2 over 3 all into plus 1. Okay. So what will this give me? We have a0 equals to, so when I add this, I'm going to have this should be 5, right? 5 over 3, right? You can press that in your calculator. 5 over 3 multiplied by, so you will have this to be 3, is it not? Yeah. So when I multiply this together, I'm going to have a0 over 5. Okay. Now you can take a look at that carefully and you find a way out of it. Now when n equals to 1, so what will I have here? I will have 1 plus 1, which will be 2. And on the other side, we have a1 all over. So carefully you observe this. I'm going to have 2 over 3 as c, right? And n as 1 now. 1 plus 1, that's plus 2. Okay? Then here I'm going to have 3 into bracket 2 over 3 plus 1, is it not? 2 over 3 plus n, so that's plus 1 plus 1. So if I simplify that, I'm going to have a1 over, so I'll look at the first bracket, I'm going to have, that's 8 over 3. Then for the second one, I'm going to have into brackets. If you get this, we are going to have 5 over 3. Then if we cancel 3, we are going to have 5 plus 1, we are going to have 6. Right? So here I'm going to have my final answer to be a1 over, so when 3 goes in this, that's 2, we have 16. Right? Then when n equals to 2, so I say I'm going to stop at a3. I said for your exam or test or anything, you can stop at a5. Okay, so when n equals to a2, what will I have? I will have a into, so now n is 2. Come to our expression again. This 2 plus 1, that's 3. So I'm going to have here to be 3 equals, okay. So if I have 3 equals, we are looking at the expression. This is it here. So I'm going to have a2. Is it no? A2. So anywhere I see n now, I'm going to put 2. Don't forget. So I'm going to be having here to be 2 over 3. So when I put 2 plus 1, that's plus 3. Right? Okay. Then look at this. I'm just going to replace it by 3 into brackets 2 over 3. So you see 2 over 3, right? Plus n, which is plus 2, plus 1. So I know. So simplifying this, what will I have? I'm going to have 8 to be. So when I multiply this, I have 9 plus 2. I'm going to have 11 over 3, right? So in the second bracket, I'm going to have this to be 8 over 3 from previous calculation. Then 8 over 3 times 3 is going to give me 8 plus 1 is going to give me 9, right? Okay. So if I should do that, I'm going to have 8 over 8 over, so I'm going to have the here is 11, right? So 3 in here, 3 here, 1, 3 here, 3. So if I multiply 11 times 3, I'm going to have 3. Okay, so from A2, yeah, from A2, we are told that A2 is equal to A1 over 16. So I'm going to replace this as A1 over 16. So I'm going to have finally that A2 equals A1 over 16 over 33. So that will be A1 over 16 times 33. So you can press your calculator and okay, so we have the answer to be 528. Now I'm going to write the general, we are trying to, the question says we find the general solution. Yeah, find the general solution. And I've said the general solution is of this form. That's what we said there. So for when c is equal to 0 now, so what would the general solution looks like? Why this is the general solution? Let's recall. So we can recall this, that this is the general solution. So that means when n equals to 0, I'm going to start from when n equals to 0. So when I put, because it's saying we should start from 0 to infinity. So I said, I'm going to be stopping at n2, right? So you can stop at n5. So when n equals to 0, if I put 0 here, I will have a naught. Now, n is 0 and c is 0. C is 0 at this point, down. This first equation down. This is general solution that I'm trying to get. So when this is 0 plus 0, so this will be 0 together, then x raised to power 0 is 1, so a naught will be there. Plus, because it's summation, so plus. Now look at this, when n is equal to 1, I'm going to have a1, right? C is still 0, so this is now 1, so I'm going to have x. Then when it's 2, I'm going to have a2 x raised to power 2 plus, so keeps going like that. You can stop at 5. So that is how you are going to write the equation. Then what will be my final answer for that one? I'm going to have a naught. We said from the first derivation that we did, from this first, we said a1 is equal to a naught. So a1, I can replace it as a naught x plus, now we said that a2 was a naught over 8. So I'm going to say a naught over 8 x squared plus till infinity. So that's the first one. Then now, this is for, let me write it there so you can know, this is when c equals 0. So now when c equals 2 over 3, so our general form will be y equals, now if I put the first one, when n is 0, right? So I'm going to have a naught x raised to power, c is now 2 over 3. 2 over 3 plus 0, that's 2 over 3. Okay. Then plus a1, n is now 1 now, plus x to the power. So I'm going to have 2 over 3 plus 1. So 2 over 3 plus 1, what is it going to give us? It's going to give us 5 over 3. Okay. Plus a2 x. Now a is 2, right? So if I have 2 over 3 plus 2, what am I going to get? I'm going to get 8 over 3, right? Plus, so I'm going to be stopping there. What am I going to get as my final answer here? I'm going to have y is equal to a naught x to the power of 2 over 3 plus, now what is a1? A1 is, okay, I think that's it. What is a1? A1 is a naught over 5, right? A1 is a naught over 5. So replace it as a naught over 5 x over 5 over 3. Then what was a2? So a2 is a1 over 16. So I'm going to have a1 over 16 x raised to power 8 over 3. I think we still have a3. So let me say a3 is now a1 over 5 to 8. So a1 over 5 to 8. So if we have a3 here, it will be a3 into x raised to power 11 over 3. So what I'm going to have is s raised to the power 11 over 3 plus infinity. So this is what we are going to have as our answer. So we have this and this. That's the final answer. So this Frobenius method is the kind of method we apply in different series solutions to differential equation, like the legendary, the Basel, and other power series. So we have made a video on legendary equation and and on numerical solution to differential equation like on Tutor Euler's method. Yeah, thank you.